You're listening to the Banana Data Podcast, a podcast hosted by Data IQ. I'm Triveni.
And I'm Will.
And we'll be taking you behind the curtain of the AI hype, exploring what it is
and what it isn't
capable of. Today, we're focusing on the future of AI, interviewing a senior researcher at Google Brain, and exploring what's overrated and underrated in the field. Last time we chatted, Will, we talked about the mundaneness of AI, right? The ordinary AI that people are doing all the time. But I guess we should also probably talk about the future, right? And maybe what's exciting and coming up.
Agreed.
Yeah. You know, it's funny. There's a lot going on out there, right? There's GANs, there's reinforcement learning, there's new forms of cloud computing. And I think it's kind of hard to make sense of it all.
Yeah, I think today, as we look to the future of AI, when I think about the future of AI, I think about kind of parallel paths. So one path, I think about people like our guest for our conversation today, Azalia, who's a researcher at Google Brain, really on the forefront of the technical challenges facing AI, thinking about the super sexy algorithms or the super complex and performant hardware that's needed to do complex AI tasks. Like, that's one path. But another path that I think has been a theme of this program is just the difficulty and complexity of human interaction and human systems and organizations actually productionalizing AI. And so I always, in my mind, think about the future of AI very much along those two dimensions. Like, how good are our convolutional neural networks going to get, A, but then also how good are organizations going to get, or how savvy are organizations going to get with regards to data collection, model building, model training, model implementation. So those are the two dimensions along which I think about this.
Well, and they're kind of, I would say, two ends of the same spectrum, right? Because, yeah, you can have these great advances in neural networks and hardware and all the like, but if you don't even have good data up front or a well thought out sort of question and goal for your AI, it has no future.
Yeah, and I think one thing that's exciting to me at the moment is, we're in an AI summer, I would say. People are still excited about this, and therefore we have a lot of different entities working in harmony. So we have businesses, we have organizations like Data IQ that are thinking about how you can get people to work together intelligently on a data problem, but you also have masses and masses of people at Google just thinking about optimizing and reinforcement learning algorithms. Like, we have a good ecosystem of human talent kind of working all the problems at once. So therefore, to me, it's fun. It's like we have this rising tide. It's all coming about together. Whereas, to your point, if one link were missing in the chain, then we'd be stuck.
So is there anything right now in the field that you think is highly overrated?
Overrated? Yeah, sure. I think the concept of reinforcement learning that I hear thrown around a lot is still overrated to me. And so I understand the benefits, I think, of real-time learning and the ability of reinforcement learning algorithms to be a little bit more innovative in the way that they learn. The reason why I have problems with reinforcement learning, and again, happy to have listeners please write in and tell me all the ways in which we're wrong here. But the ways that I see your reinforcement learning being flawed, it's that to engineer in a production-ready system for a business is hard, right? You have to have that system in place to get real-time feedback to your algorithm so that it can learn these strategies. And we've talked about some before, things like Stitch Fix and multi-arm bandits and their way they send email advertising. But in general, I think implementing reinforcement learning algorithms is pretty tricky. So I don't know, maybe I'm scaling back enthusiasm on that a little bit.
So maybe it sounds like the infrastructure is underrated.
Yeah.
AI infrastructure or DevOps around it.
Yeah. So I think about AI as relying on infrastructure. Like, you need a computer to do most AI, I think. You also need data to do most AI, I think. And then you also need math or algorithms or statistics, some combination of those three to do AI as well. So I think those things very much work in tandem. And so they need to, again, kind of all rise together. What about you? What do you see as underrated in the AI landscape?
So for longtime listeners, you're not going to be surprised by my next statement. I think that responsible AI efforts are severely underrated, right? So there's a lot of lip service. There's a lot of discussion around we need to do X, we need to do Y. But the actual methodologies, right? The algorithms, the practices that are required to do responsible AI or to be responsible aren't getting a lot of traction, right? There's a lot of niche research out there, but it's not widely sort of accepted, integrated into data science practices. And frankly, I think we need to make some big efforts there.
Agreed.
With us today is Azalia Mirhoseini, a senior research scientist at Google Brain, and also recently named one of the 35 innovators under 35 by the MIT Technology Review. So welcome to the show.
Thanks for having me. Glad to be here.
So one of the famous taglines about you is the woman who taught an AI to design AI chips. Could you maybe walk us through a little bit by what exactly you're doing? Then we'll dig into a little bit later how this is relevant for people who are at organizations other than Google Brain.
Since the beginning of my PhD, I have been working on machine learning algorithms for optimizing computer systems. And when I joined Google, I kind of continued doing that, but now with the newest tools and algorithms that were founded in deep learning and reinforcement learning. So the idea behind my work is the following. Deep learning and machine learning in general, a lot of its success is due to the powerful computer systems and hardware that key enablers for these methods. A lot of these neural network algorithms existed decades ago, and really the rise of new computers were one of the key factors to enable them to shine these days. Now, it's really time for us to return the favor and basically use machine learning and develop new machine learning techniques that can later on go and develop new computers and chips. So kind of closing the loop of developing hardware for machine learning such that our machine learning algorithms can later do better, more interesting tasks.
So it sounds like you're almost trying to prevent another AI winter, right? Because the AI winter kind of hits when funding runs out or we reach a threshold of we can no longer process this data anymore. Is that right?
I would say we all know Moore's law is that, which predicted that the amount of computational power we can get doubles every 18 months. On the other hand, there was this recent study by OpenAI that was showing that the largest AI runs, the successful AI runs, the amount of compute they use doubles every 3.4 months. So Not only Moore's law is dead, but to keep up with the computational demands of AI, we really need to rethink the way we design hardware and design computer systems that run those machine learning and AI algorithms.
I would imagine you have a bias here given your background and your work, but first of all, I'll present you with a premise and then you can answer the question. But I would think, or I do think, of development AI as being reliant on computer systems or what I'll call hardware, and then mathematical methods or algorithms kind of as a second bucket. So the interaction between the hardware and the software. And then third, it also requires data. So you have some powerful neural net that requires a GPU or a TPU. You have a cool algorithm, and also you have a lot of data to feed that model. Which of those three do you see in 2020 and beyond as kind of the big roadblock that we're facing in the field at the present? Hardware, algorithms, data. Where should we be investing our time?
So I'm a bit biased, and I would say hardware is definitely some of the biggest focus areas in 2020. But of course, the other two pillars, data and algorithms, do matter a whole lot as well. The thing with hardware is that it is very hardware design is a really complex task, and it's very time consuming, and also it's very expensive. So the rate of generating new hardware and at the same time new computer systems is much slower than that of algorithmic design and data collection. That's why it definitely needs a lot of focus and attention, especially given the insatiable demand for compute in AI.
So it sounds like we can't develop new algorithms until we have the hardware to deploy it. Is that kind of what you're arguing?
Like right now, we have great hardware. We have GPUs, CPUs, and sure, there's still a lot of algorithms that can be developed for the current hardware that we have. But if we are looking into next generation of algorithms, we are really not using a lot of nice features in a model. For example, sparsity, like very adaptive, quantized models and such, that can bring a lot of efficiency to these algorithms, And the reason we're not using them right now is that the current hardware can't really take advantage of a lot of these properties. So that makes scientists not develop those algorithms because they don't gain anything from a hardware perspective. It might even slow down training of the algorithms. They might not get performance accuracy from them. But if we kind of co-develop and co-evolve like hardware and algorithms, that's where there's hope for a new generation of highly efficient AI algorithms.
It's a sort of a chicken egg situation, I would imagine, where you need progress in one domain to drive progress in the other. One thing we try to do on this podcast is, I think, distill complex or mythological concepts for our listeners. And so one thing that comes to mind for me through this discussion is the idea of quantum computing. So something that people are talking about, like most people, including myself, don't know much about it, right? There are qubits and zeros and ones together, and it's all very exciting, but that's really all I know. For people like myself who are, working on the ground level in the data science space, what do we need to know about quantum computers? Or can we just, leave it to you for the next decade and then come back in 2030?
I think that's definitely a very different way of thinking about hardware. Google recently has made a lot of progress in that, but we're still like years away from quantum computers to be used in our everyday AI applications. So I would say there are a lot of great fundamental research is being done on that, but at the same time, we don't want to wait on them to work. We need a lot of work to do on the more traditional hardware design and system design methods right now while we're waiting for them to develop.
Yeah, that makes sense. Triveni and I spoke actually on the last episode a lot about just don't over-engineer, right? If something's simple and it's working, stick with it. So maybe, again, in 2020 at least, sticking with the good old CPU or GPU or Google's TPU as hardware instead of a quantum computer would be the way to go.
So based on everything that you're sort of at the cutting edge, right, of this new developments and sort of in the field, what are you excited about for the next 10 years of AI?
10 years is it's like a lot in this field right now. It seems like I think maybe in the next, I can talk mostly about the next like 2 to 3 years. In general, I think I mentioned earlier, I'm really interested in meta learning algorithms, and that basically is algorithms that can create new type of optimization algorithms themselves. So instead of us, human experts optimizing for different optimization objectives, we let algorithms do that. And that's where we gain a whole lot more efficiency and potentially like we can open new doors and solve new problems that we can solve the way we currently design our algorithms. And in terms of applications of these methods, definitely hardware design is one of the areas that I'm interested in. But of course, other places where this comes in and AI can come in would be, and that can be life-changing, would be self-driving cars, different ways of communication and delivery of information and goods and everything. These are the things that I think hopefully change a lot for the better in the next 2 to 3 years.
On this topic of meta learning, I think our listeners may be familiar with the concept of hyperparameter tuning or hyperparameter optimization, where you have a designed algorithm, but that algorithm has to have had prior choices made about these things, which we call hyperparameters. So I'm less familiar with meta learning. Could you describe how it's similar or different to just things like searching hyperparameter spaces?
So meta-learning can have different meanings, but in terms of searching hyperparameters, that means the algorithm is already there, right? You're just up-tuning it with the right hyperparameters to get maximum efficiency from that. But meta-learning is that how we design those algorithms, how do we come up with those hyperparameters? Instead of ourselves as designers, we let algorithms come up with those hyperparameters and come up with the optimization process. For example, an example of it would be we have a target optimization metric, a reward function we want to optimize, and we have different ways to get to this optimization objective. And a lot of times when we design an algorithm is that how we put together these different skill sets and such to optimize the algorithm. instead of us doing that, what if we kind of let a meta learning algorithm come up with strategies to optimize for the target objective? The reason this is a complex task is that the search space for all of these strategies can be really huge. That's why us humans are very good at picking the right, like we have intuitions, we pick the right sub areas and we optimize tasks. But the power of these meta learning algorithms is how they can search over this massive space of optimization and come up with ideas and strategies that is much harder for us as human experts to come up.
So kind of a whole different universe from just simple hyperparameter optimization. So I definitely have my homework.
Well, but I mean, that sounds a little bit like you're taking the human out of the loop. Could someone argue that you're going to take away the jobs from data scientists and all of these people who have spent so many years learning hyperparameter tuning or whatever it might be?
I think the idea behind all of this work is to increase efficiency, and that could be efficiency in terms of performance of algorithms or the engineering efficiency. And the way we can think about it is that if we do some of the tasks that are better for a computer to do, then we can free up human expert time and they can do more interesting, more challenging things. I don't think there is a lack of things to do for all of us. So even algorithms can become better at us in optimizing some hyperparameters. There are other bigger problems that we can think of and new challenges that we can think of that hopefully this will just free up our time to focus more on the bigger challenges.
One thing we ask guests on this show is how others can help you. So if I'm working as a data scientist at a firm here in New York, or I'm managing a team of analysts or machine learning engineers, what do I need to know to help you, Azalia, and you, Google Brain, kind of make progress faster or more efficiently? Or should we just let you do your work and check back in with you every January?
No, I think that already in the AI community, there is like very good flow of information, say Twitter and all these websites all these tutorials, videos on YouTube and such. So I think what makes the AI community like grow together so fast is that we kind of, ideally, we want to adopt the latest techniques, latest optimization, and kind of take them on and improve them if possible and share them with others, share our progress with others, share the challenges that we see, the drawbacks, the advantages. So I think that's and AI community in general is this very open, very into open source and like very into communicating latest information. So I think that's like what we should continue to do. And that's what makes us grow faster together.
I think that's sort of a critical part of this is that, and we've actually had, a hardware engineer on the podcast before, and he said the same thing that, being able to discuss and share across is really important. I hope that, in the next couple of years, someone or somebody makes some sort of maybe like a public forum or something where there's like an actual interface between folks like yourself and maybe more hardcore algorithm developers. Like the work that you're doing at Google Brain, there's no reason why that model can't be replicated, right? Where hardware, hardware, software, and data practitioners can all sort of come together to build the next generation.
And unfortunately, at Google Brain, there is this culture of open sourcing. So we do publish a lot, we do communicate, we give talks and such. And definitely that's a way for all of us to move the field forward faster together.
Cool. All right. So given that you are, really advanced in this field and you know a lot about different parts of AI, we wanted to play a little game called Underrated, Overrated, or Just Right. So give us an opinion on whether the following subject is underrated, overrated, or right where it needs to be, and maybe give us a little reason why. So
reinforcement learning.
Underrated?
Underrated, why?
I strongly believe that in the next few years, we are going to see a lot of applications of reinforcement learning to many real world optimization tasks. The reinforcement learning is really powerful because it can optimize tasks that are beyond just a simple labeled data classification and regression tasks. It can come up with strategies towards reaching goals, and that's like what makes it more exciting and more powerful.
What about neural networks and deep learning?
I would say just about right. They have already had a lot of impact to a lot of real world problems that we deal with. And we are going to see more of the changes towards more efficient, better systems and environments are enabled by deep learning. But there's a lot of excitement around this. So that's why I'm just saying it's just about right.
On that thread of efficiency, so do you think when you're looking to the future of AI, particularly deep learning, that efficiency is really going to be a focus? Because one critique that I and others might have of deep learning techniques is that to some extent, it seems like advances that have been made recently, and excuse my ignorance, I'm sure this is going to offend many people, but in many ways, it's been more data, simply deeper networks and longer training time. So just kind of throwing more resources, but not necessarily in a much more efficient way. So do you think that's the case, or am I mistaken?
Certainly, like using more data and using larger models are going to help us get better results. But a lot of times those are for supervised algorithms. And I think we already, all of us can agree that we're doing pretty well on any supervised learning task if we have enough data and such. But I think a lot of the recent progress in AI is not, the interesting part is not on the supervised tasks. Instead is on unsupervised and semi-supervised learning, as well as in reinforcement learning and other meta-learning algorithms. And those are the things that, again, some of those would benefit from more data and some of them don't. We are definitely witnessing a lot of innovation in the algorithms that are independent of the data or the size of the neural network.
What about the cloud?
I would say it's just about right. As we just discussed, a lot of machine learning models work well and train well if they're trained on distributed computing systems. And a lot of times for that, we go to cloud. As we get more and more data and the type of applications that we want to optimize with AI increases, we definitely need to focus more and more or migrate more and more to the cloud.
Okay. And last one here. What about responsible AI, ethical AI efforts?
I would say that's underrated. There's a lot of focus and efforts on ethical AI, and that's great. But we definitely need more awareness of that because we can have biases in data, in our algorithms and models, that dealing with them and kind of avoiding them is a very challenging task. So we definitely need more researchers and more scientists think really deeply about these problems and come up with solutions that makes us have more fair and responsible AI models.
Yeah, and definitely looping in people from outside the scientific community, right? Because they
definitely
conceivably have been working on this for a long time. Yeah.
Yeah, it's not just the scientists, everyone who is involved in the cycle of going all the way from collecting data, finding the problem to coming up with an answer. We all should work together towards more responsible AI.
It sounds like, you think things are underrated and just right. So I feel like the state of AI is in good hands, especially with you going forwards. But I think that's probably all we have time for today. I know I have learned a lot.
I have learned a lot. This has been a great conversation.
Thank you. Thanks for the fun questions.
Thank you so much for your time. And for our listeners, we'll be sure to have more on Azalia's background and prior work in the show notes.
Okay, so time for the banana fact of the episode. And this one's really exciting, especially for geography nerds. So if you walk south of Detroit, right? You go south out of Detroit, across the Detroit River, you'll end up in Canada, right? I encourage our listeners to go to Google Maps and look up Windsor, Ontario. It is actually physically south of Detroit.
That's all we've got for today in the world of banana data. We'll be back with another podcast in 2 weeks, but in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Triveni.
It's been great, Will. See you next time.